Terraform, created by 𝐻𝐸𝐶𝐏, is a configuration orchestration tool as well as an open source software tool. 𝐻𝐸𝐶𝐏's Terraform has a market share of 4.82% in the configuration management market. Top industries that use 𝐻𝐸𝐶𝐏 Terraform for configuration management are DevOps, Cloud, and Kubernetes. Around the world in 2021, over 591 companies have started using 𝐻𝐸𝐶𝐏 Terraform as configuration management tool. Hello everyone, this is Dhruv from Edureka and I welcome you all to this session where I will be talking about GCP Terraform. So without any further ado, let's take a look at today's agenda. We will start this session by first having an overview of Google Cloud Platform, and then we will understand why one must go for Terraform and what actually it is. After that, we will get a brief of tools for using Terraform with Google Cloud Platform as well as Terraform support for GCP. And then finally, we will try our hands on Terraform supported by GCP. Before we begin, do consider subscribing to our YouTube channel and hit the bell icon to stay updated on trending technologies. And also, if you are interested in online training certification in Google Cloud Platform, check out the link given in the description box below. So first, let's get an overview of the Google Cloud Platform. Offered by Google, it is a suite of cloud computing services that runs on the same infrastructure that Google uses internally for its end user products, such as Google Search, Gmail, file storage, and YouTube. Along with a set of management tools, it provides a series of modular cloud services including computing, data storage, data analytics, and machine learning. For organizations with large amounts of data to store or analyze, Google Cloud Storage prices are up to 20% cheaper than AWS, and the price of database services also compares favorably. While there is no difference in the price of container services, Google Cloud is an industry leader in the field and is also investing heavily in AI and machine learning technologies. Many small and large enterprises are increasingly adopting Google Cloud Platform, which bodes well since it disengages things and makes them more secure at reasonable costs. Let us now see the reasons why one should consider Terraform. So Terraform lets you define infrastructure in configuration code and will enable you to rebuild and track changes to infrastructure with ease. So Terraform provides a high level description of infrastructure, which means it's infrastructure descriptive. Second, it has a lively community and is open source. There is a massive community developing around this tool. Many people are already using it, and it's easier to find people who know how to use it, like plugins, extensions, professional support, etc. This also means Terraform is evolving at a much faster rate. They do releases very often. So third is speedy operations. So Terraform's speed and operations are like exceptional. One cool thing about Terraform is its plan command lets you see what changes you are about to apply before you apply them. Code reuse features and Terraform tends to make most changes faster than similar tools like CloudFormation. Also, it is like the right tool for infrastructure management as many other tools have a severe impedance mismatch from trying to wrangle an API designed for configuring management to control an infrastructure environment. Instead, Terraform matches correctly with what you want to do. The API aligns with the way you think about infrastructure. Also, Terraform is the only sophisticated tool that is completely platform agnostic as well as supports other services, while there are a few alternatives, but they are focused on a single cloud provider. There's a declarative code. So Terraform enables you to implement all kinds of coding principles, having your code in source control, the ability to write automated tests, etc. Now that we have understood why one must choose Terraform, now let's briefly understand what Terraform actually is. Terraform is a configuration orchestration tool designed to provision the servers themselves. It refers to arrangement and coordination of automated tasks resulting in a consolidated process or workflow. So it is also an open source tool, means open source software tool created by 𝐻𝐸𝐶𝐏. So 𝐻𝐸𝐶𝐏 created Terraform to manage present as well as popular service along with the custom in-house solutions. So Terraform lets you provision Google Cloud resources with declarative configuration files, resources such as virtual machines, containers, storage, and networking. Terraform's infrastructure as a code, that is, IAC approach, supports DevOps best practices for change management, which lets you manage Terraform configuration files in source control to maintain an ideal provisioning state for testing and production environments. Terraform manages external resources with providers, external resources like public cloud infrastructure, private cloud infrastructure, network appliances, software as a service, and platform as a service. HashiCorp maintains an extensive list of official providers and can also integrate with community developed providers. Users can interact with Terraform providers by declaring resources or by calling data sources. Rather than using imperative commands to provision resources, Terraform uses declarative configuration to describe the desired final state. Now let's look at some tools for using Terraform with Google Cloud. We will briefly understand these tools. So there are like variety of tools you can use to optimize your Terraform experience. So first, let's explore the Cloud Foundation Toolkit, which provides a series of reference modules for Terraform. The modules reflect Google Cloud best practices, and using these modules help you get started with Terraform more quickly. The modules are documented in the Terraform registry and open sourced on GitHub. So these are some of the features of Cloud Foundation Toolkit. So first is ready-made templates. So the Cloud Foundation Toolkit provides a series of reference templates for Deployment Manager and Terraform, which reflect Google Cloud best practices. These templates can be used off the shelf to quickly build a repeatable enterprise-ready foundation in Google Cloud. This frees you to focus on deploying your applications in this baseline secure environment, and with infrastructure as a code, you can easily update the foundation as your needs change. Second, like you can treat your infrastructure like software. So through the open source templates, you can automate repeatable tasks and provision entire environments in a consistent fashion. Plus, your teams can collaborate on the infrastructure by participating in code reviews and suggesting source code changes. Third, it's like built for enterprise. So the Cloud Foundation Toolkit is designed especially to meet the compliance and security needs of enterprises. By creating a foundational environment using these templates, you can be confident that best practices are implemented out of the box, including key security and governance controls. Also, you can like maintain consistency easily. By adopting the toolkit, you can be confident that different teams are deploying their applications and environments using a consistent set of tools and patterns. This reduces the potential for misconfigurations and inconsistencies while allowing easier collaboration across different teams. Also, you can choose your adoption strategy. Each template from the Cloud Foundation Toolkit can be used independently. You can choose which patterns make sense for your organization and add new ones as your environment evolves. The open source templates can easily be forked and modified to suit your organization's needs. Lastly, you can save time and resources with pre-built templates. With the Cloud Foundation Toolkit, you don't need to spend time developing your own templates and patterns for Google Cloud. Instead, you can build an open source templates and focus only on the customizations which are required to your company and workloads. Developers can like move faster and migrations are less time consuming because of it. So the second tool is Terraform Validator. So leverage Terraform Validator to enforce policies on Terraform configurations for Google Cloud. So Terraform Validator is a tool for validating compliance with organizational policies prior to applying Terraform plan. It can be used either as a standalone tool or in conjugation with Forseti or other policy enforcement tooling. Terraform Validator relies on policies that are compatible with Config Validator. Note that using Terraform Validator does not require an active installation of Forseti. Terraform Validator is a self-contained binary. So you can see the Forseti config validator shown here, which is the newest addition to the Forseti security toolkit. So config validator helps cloud admins put guardrails in place to protect against misconfigurations in Google Cloud Platform environments. This allows developers to move quickly and give security and governance teams the ability to enforce security at scale. So how does a Terraform validator works? So cloud admins write security and governance constraints as YAML files once and store them within their company's dedicated Git repo as a central source of truth. Then Forseti ingests constraints and uses them as a new scanner to monitor for violations. Then Terraform Validator reads the same constraints to check for violations before provisioning in order to help prevent misconfigurations from happening. That's how the whole process of Terraform Validator works. The next tool we have is Terraformer. So by importing existing Google Cloud resources into Terraform with Terraformer, it is a command line interface tool that generates TF or JSON and TF state files. Terraform already has existing resources in your environment, performing the reverse of what Terraform is designed to do. This tool can be thought of as infrastructure to code. Next and the last tool is a Cloud Shell. So Terraform is integrated with Cloud Shell, and Cloud Shell automatically authenticates Terraform, letting you get started with less setup. Using Cloud Shell, you can manage your infrastructure and develop your applications from any browser. Cloud Shell is an online development and operations environment accessible anywhere with your browser. You can manage your resources with its online terminal preloaded with utilities such as the gcloud command line tool. You can also develop, build, debug, and deploy your cloud-based apps using the online Cloud Shell editor. So some of the features of Cloud Shell are like full power access from anywhere. You can manage your Google Cloud resources with the flexibility of a Linux shell. Cloud Shell provides command line access to a virtual machine instance in a terminal window. Then it has a developer ready environment, so you can develop your apps directly from your browser with the Cloud Shell editor, streamlined to increase your productivity with features such as Go, Java, Node.js, Python, and C language support. An integrated debugger, source control, refactoring, and a customizable interface. Run your app on the Cloud Shell virtual machine or in the Minikube Kubernetes emulator. Preview it directly in your browser, then commit changes back to your repo from your Git clients. Then the next feature is like your favorite tools pre-installed and up to date. So many of your favorite command line tools from Bash and sh to Emacs and Vim are already pre-installed and kept up to date with Cloud Shell. Admin and development tools such as command line tool, MySQL, Kubernetes, Docker, Minikube are configured and ready to use. No more hunting around for how to install the latest version and all its dependencies. Just connect to Cloud Shell and go. So the last feature is cloud code tools for maximizing development productivity. With this, you can easily develop cloud-based applications with the tools provided by our cloud code extensions, allowing you to develop and deploy your Kubernetes and cloud run applications, manage your clusters, and integrate Google Cloud APIs into your project, all directly from the Cloud Shell editor. So now let's understand like the support that Terraform provides for GCP. The core Terraform command line interface is developed by 𝐿𝐿. Use the following resources for support, like for provider related issues, open an issue on GitHub. For questions about Terraform in general and common patterns, check the 𝐿𝐿 community portal. For general troubleshooting advice, see Terraform's debugging documentation and join in the Google Cloud Community Slack Terraform channel. If you haven't already, you can like register for the Google Cloud Community Slack. Now that you have a theoretical understanding of Terraform with GCP, let's demonstrate it practically with an example of launching a virtual machine instance in GCP through Terraform. So the first step is to download the Google Cloud SDK installer. So just search out Google Cloud SDK. So go here. So you can just directly go to the install section here. Yeah. So yeah, here like if you have a Linux OS, you can go to Linux and follow the steps to download, or you can go for Mac OS also. Because I have Windows, so I will start download directly from here. So I got it downloaded. Okay, open. Takes a few seconds. Yeah, let's go next. So I already have a SDK installed, so I don't have to continue. But if you don't have SDK installed, so do continue, like get the installation complete. So yeah, the next step is to download your Terraform. So you can just directly go to releases.hashicorp.com/terraform. So HashiCorp, as I've told you, is the company that created Terraform. So from here, like all the versions are given, a lot of versions are there. So you can just go and download one. Yeah. If you have a Linux OS, you can just copy the address from here and unzip it. Okay, that's what you have to do. So if you're a Windows user, you can just download it from here. Yeah, it got downloaded twice, so you can delete this one. Yeah, so you can just extract it from here. Yeah, you got it. Just copy it and paste it somewhere where you are going to like place other files like separately. Like I have a different place to copy, so I will just go to my section, like not here, just a second. Okay, I will just go to my place, like because I am going to provide the path also. I will keep that in mind to place it separately in demo section in the Terraform. Yeah, like this one I have got it before, so I will delete this one and I will paste the new one. Yeah, I will name it as Terraform only. So the next step is to go to the build infrastructure. So here go to the HashiCorp website. From here you will go to the tutorial section of the Google Cloud. Okay, the prerequisites are given, like you have to create the account on Google Cloud platform. So if you don't have an account, create one. It's a very good platform to have your account on, and it provides a free trial, like it's given the free trial. So free trial account is provided for 90 days with $300 credits. And when you're going to register it, you'll ask for your debit or credit card details, and it will just debit 1 rupee, and that will also be refunded very soon. Also, like $300 credit is provided, so that is like a lot of credits. Even means the exercise which I'm going to provide you, it's like it doesn't cost anything. It will only cut around $15-20, not more than that, or maybe maximum $50. That's it. So that's how you can use it. So next, CloudShare. CloudShare I've already explained you how it works and what are its features. Then is set up the GCP. So what you have to do in the GCP is you have to create a project, then you have to create a service account, and you have to generate a key. Okay, so let's go to the GCP console. So this is how the GCP console, like Google Cloud Platforms console, looks like. Okay, from here you go here and create a project. So you can create a project from here, but I already like created the project. My project name is demo, so I will use this project only. So now what I have to do is I have to make a service account. So I will type service account, and yeah, this is the default one, and this is the one I have created recently. So I will create a new one with the name TF demo. For service account, we will name it as SA. Okay, so create and continue. Now for access purpose, you have to give the role. So like different access options are provided for, like different services are here. You can provide like for a specific service you can provide the access, like app engine or AI notebooks and everything, auto ML, CA service, cloud asset, cloud data labeling. For a specific service, which for whatever purpose you want to give, you can give it specifically. For this service account, I want a complete access, so I will just go to the project, and in project I will give the owners to get the complete access. So yeah, continue. Done. So yeah, the service account is created for TF demo SA. Okay. For the next step, you can go to the registry Terraform that I've already opened. Okay, in this way you have to go to the getting started with Google Cloud Provider. You will get the code for here, the basic code for virtual machine launching the instance. It's simple, this one, and it's the basic code of Terraform. Okay, so if you're going to use AWS now, so in AWS you will just use, instead of Google, you will use AWS. That's it, all the things will be same. And similarly the provider code is provided below, so just copy this code also and make a provider file, and for this create a VM file, like I have created one. So this is how I have copied it here, like this is the VM, the basic codes, and then the provider code is provided here. So you can see in VM, like the credentials are given, project and then region is given, everything. And similarly, like the provider in this, the name, like with the virtual machine instance that will be created now, that will be named by Flask VM, and whatever the ID it will be there. So in that name, the virtual machine will be created. Similarly, machine type is given and zone is given. Also, one more thing. So I have to generate a key in this, like this I have created now. I have to generate the key. I have, like, remember I told you in this, like the third step is to create a service account key. So you can go here, like the service account we have created. In that we have to create a key. So manage keys and add key, create new. So in JSON file here will be created from here. So yeah, got created. So we can just go to downloads. Yeah, so it is here. So we can just copy here and you will just paste it where we have all the Terraform files, and name it as tf underscore authorization underscore, sorry, tf underscore demo underscore authorization. This is what I have named in the code also, that's why I'm naming this. So yeah, tf underscore demo underscore authorization.json. So that's what it is, same. So coming back, so yeah, all the codes and everything is done. So now what we have to do is take that. So it's the key is active now, you can see. So what we have to do is now open the command prompt. You just have to provide the path first. So the path is cd demo slash terraform. So yeah, the path is here. Then we have to revoke the authorization. So gcloud authorization purpose, for gcloud authorization revoke. One more thing I will show you, the JSON file. If you see, everything is given like privately. For project ID is given private, key ID is also given. From the name, the virtual machine will be launched now, the key will be given this Flask ID and the key. Then private key is given, then client email, client ID, authorization token, everything is given in this. Okay, so we got this authorization revoke, credentials are here. So after that we have to configure. So gcloud config configurations list. So yeah, though everything is right in my account, but if you want to change, so what you can do is you can initialize this. So first clear this one. So you can initialize it for changing anything in your configuration list. Okay, so gcloud, oh sorry, gcloud initialize init. So yeah, for reinitialize, give the choice numeric number 1. It's been done. Then would you like to log in? Yes, I want to log in. Just have to log in from here, allow, and it's authenticated. It will be done now. So you can just come back. You can choose the project from here. So your project name is, if you remember, it's Chrome Sensor 313404. Okay. So it is Chrome Sensor. So it's second. And I think then yeah, the zone and region we have to select. So yeah, we want to select. So my region is South Asia. Yeah. So I will select 37 South Asia 1A. So yeah, everything is done now. So we can just again configure now. So yeah, everything is at place. Account, yeah. So last time, if you see, like I was saying, like everything is right, but last time also like everything wasn't right, because in the place of account, my account wasn't selected, so it wouldn't have worked. Do check it properly. Then just clear this. Then let's start with the Terraform initialization. Terraform init. We have to go with, I think, yeah, it's getting initializing. So yeah, it's got initialized, and we go with plan. So Terraform, sorry, caps lock initialize. I have already initialized that, sorry. So Terraform plan now. So yeah, so it will be like create. So if you like got done, but you can go, so you can see like Google Compute instance will be created now. Okay, so what we have to do is we just have to apply. So here the command is Terraform apply. Only yes will be accepted. So yeah, yes, yeah. So it's got created. So let's check. Let's go to the virtual machine instance. Pure engine, virtual machine instances. The flask will be created with the name flask, or some ID will be given again. Flask VM ID something. I hope it get created. It will be created because it's showing, so of course it got created. Yeah, flask VM in the private ID. So yeah, that's how it got created. And if you want to delete it, you can just give the command of destroy. Okay, so you can just come here. You can give Terraform destroy. Only yes is accepted. So yes, it takes a few seconds. So yeah, so it got destroyed. Let's check. Now it is here. So we will just refresh it. We'll find that it will get deleted from here. Yeah, so it got deleted. With this, we come to the end of today's session of GCP Terraform. I hope you had a great time learning and understanding about it. And if you have any queries, please feel free to leave them down in the comment section below. Until next time, thank you.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!